All right, so one of the uses of z-scores is to determine if a given datum is significantly high or significantly low. Um, so what do we mean? So this word significantly, okay, is a significant word, okay? Um, it's a statistical word that carries a lot of weight. It's a statistical word that it means a conclusion. And that conclusion is that a number is statistically different from all the rest. Um, it's also used to determine when or to explain when a rare event has occurred. You would use the word significantly. Um, so if we look at, let's see, do I have it here? No, I don't. Um, if we look at the donut example that I had earlier, okay, let's see here. So we had 0 donuts that were taken 1, 2, 3, 4, and 5. And I think we had 3 people took 3 donuts, 2 took 2 donuts, 1 took 1, 2 took 4, and 1 took 5. Okay. So if someone walked up and they took 4 donuts, okay, that's higher than the average, right? Or higher than the mean. But we wouldn't say that it's significantly higher because it's pretty close to the sample mean. And very similarly, if someone came and took 2 donuts instead of 3, well, that is smaller than the mean, but it's not significantly smaller. It's just a little bit smaller. But what if we handed somebody with an open box of a dozen donuts, of 12 donuts, and they just took the box and they walked away with it? They took all 12. Okay, we would say that that is significantly high. Okay, so that would be significantly high. Now, from maybe a purely subjective opinion, a subjective point of view, an opinionated point of view, we would say, well, if the average is 3 and someone took 12, that's a lot. Okay. But the problem is in statistics, we can't just make opinionated values like that. We can't just subjectively say something is bigger or smaller. We need to have a mathematical basis in order to justify our decision. Okay. So that mathematical basis is, well, we need to calculate this boundary. Okay. And if we can calculate this boundary, then we can say anything outside the boundary is significantly high, and everything inside that boundary is not significantly high, right? So if we have a mathematical basis for making this boundary, then we can make this kind of conclusion, all right? So one of the purposes of z-scores is that once you've converted a data set in units to a unitless z-score, any datum with a z-score greater than 2 is considered significantly high. And any datum with a z-score lower than -2 is considered significantly low. Anything that kind of varies, has a z-score somewhere between -2 and +2, it's just within normal variation. So I'll say that's within normal variation. Or instead of normal, let me say random. Within random variation. Um, so let's look here at exam score percentage and coffee consumed in days, right? These were examples that we looked at earlier. And if we take these datums in their respective units, we want to know, well, is an exam score of 100%, is that considered significantly high? Right? Is this one considered significantly high, or um, is it simply within random variation? Okay. Um, Likewise, is a score of 64%, is that significantly low? Or is that too simply within random variation? This one with coffee consumed, so some people consumed coffee for 13 days out of 30, 14 days, 15 days, 16, 17 days out of 30. What about 19 days out of 30? Is that considered a significantly high number of days? Okay. So that's where, it can be tough to maybe judge just by looking at it. But if you have got a mathematical basis, it can make that decision really simple. So if we convert these into z-scores, okay, so here you can see this is the z-score representation of the exam scores up above. Notice it's got the same shape. I think we had a mean somewhere around 76 or 77, okay, which is where we've got a score of z equals 0 right here. And then over here, we've got our coffee consumed. So if we go to draw those boundaries at +2 and -2, any data points that are out here, this would be considered significantly high. And any data values out here, this would be considered significantly low. And in the middle, this would be within what we'd consider to be random variation. And so in this example, no datums exist with a z-score of below -2 or above +2. So none of these are significantly high or significantly low. These are all just kind of clustered together. But if we look at this other example and we draw a boundary at +2 and -2, okay, where above +2, this would be considered significantly high, and below -2, this is considered significantly low. We can see we've got one data point here, which has a z-score greater than +2. So this data point, which is drinking coffee 19 days out of 30, we would consider that to be significantly high. All right. So, just by looking at it can be tricky, but, you have a statistically valid reason for coming to that conclusion. That's what z-scores let you do. Now, why is it +2 and why is it -2? I want that to be kind of like a burning question in your mind that you're going to want to keep in the back of your skull, because we'll explain this later, why it's +2 and -2. Um, I may forget by the time I record videos later to refer to this, but you'll see why, +2, -2 just keeps recurring over and over and over again. Okay, so you will see that later. All right, so convert datums into z-scores, see which ones have z-scores above 2, below -2, and that tells you if they're significantly high or low. All right, let me know if you have any questions.